Simplify this expression. So, what is the meaning of simplifying an expression with exponents? So, today I am beginning pre-calculus lesson 2. So, here I am talking about the meaning of simplification. So, please keep on watching this video to learn that. Hello everyone, welcome back to Dona's Academy. So today I am beginning lesson 2 of pre-calculus. Before watching this, you have to watch the previous video, lesson 1 of this video series if you haven't watched this already. Okay, so in this video, I'm going to explain the definition or the meaning of simplification and expression that contains exponents. So, I'm going to talk about meaning of simplifying an expression containing exponents. All right. So originally, if we have an expression that contains exponents like this example, so we have originally one expression that contains real numbers and their powers, right? Here, x and y are considered real numbers. So we have powers, expression that contains powers of real numbers. Then if we simplify it, then that means we are converting this original expression to another expression that satisfies two conditions. So we are getting a new expression that satisfies two conditions. Now, what are those two conditions? The first one is each real number should appear only once, right? Each real number in that expression appears only once. Second condition is all exponents or the powers should be positive. All exponents are positive. If the new expression satisfies these two conditions, then we say that it is simplified. So then we can stop the calculations. All right, now let's come back to our example. Now we can see that we see x in two places and y also in two places. So it doesn't satisfy the first condition. And similarly, about the powers, we see negative powers. So it is not simplified. All right. So now how do we simplify this expression? Now we know the meaning, definition. We know how to. We know when to stop now, because if once it satisfies these two conditions, then we know that we can stop the process. So that's how we simplify an expression. All right, so let's come back to our example. We had 9, what did we have? 9x3 y negative 5 divided by 3x negative 1 y positive 2. Alright, so now how do we start? First of all, we can use the laws of exponents, so definitions and everything related to exponents. So first we can simplify here the constant 3, we have 3, and then we can rearrange these negative powers, because we know that we have 1 divided by x negative 1 here. This is same as x negative of negative 1 according to laws, and this is same as x positive 1. All right, so we can rearrange like this, and then for y terms we can write y negative 5 as 1 divided by y positive 5. So in that case we have y positive 5 in the bottom and this y positive 2 in the bottom. All right, now we have done some rearrangements to this original expression using the laws. Now, does it satisfy the conditions of a simplification? Let's check. First one, each real number appears only once. Is it okay here? No, it's not, because we see x in 2 places and y in 2 places. How about the second one? All exponents are positive. That is okay, right? We see positive exponents, but the thing is, we have to satisfy both of these conditions, right? This is not okay. This is okay, but if it is not satisfying, at least if it is not satisfying both of the conditions, then that means it's not simplified yet. Okay, so let's do more calculations here. So now we can apply other laws like the addition or the multiplication of two exponents of the same base rule, right? So if we use that here, we have 3 and here we have 1. We can add them together, then this becomes x to the power 4. And in the bottom, we have 5 and 2 with the same base y, so we have y to the power 7. All right, now we had one more step. Now let's check back the conditions again. How about first one? Each real number appears only once. Is it okay? Yeah. Now we see only one x and only one y. So this is okay. How about second one? All exponents are positive. That's also true. So this expression satisfies both of these conditions. That means it has been simplified. So we can stop the process. So this is our answer. This is the simplified version. All right. Let me explain another example. My second example is I have 1 divided by 3, x to the power 4, y to the power negative 3, whole thing to the power negative 2. Alright, so let's first, even we can check the conditions for the original expression. If it is already simplified, then we don't have to do anything, right? So let's check it for this original expression. Each real number appears only once. That is okay, but not all exponents are positive here. So we have to do something to come to this step, right? Okay, so now what can we do? We can apply power of power rule. However, we see negative powers here. Now, even though I proved the laws of exponents for assuming that the exponents are positive, if you remember that, if you don't remember that, please go back to that video. I have also copied a link for that lesson 1 in the description of this video. So please go back to that video and check how I proved the laws. There I actually was assuming the exponents are positive. However, we can apply the same laws even if we have negative powers. It doesn't matter. It's still true, right? So we can use the power of power rule here. And we see a product of three things. So we can use another rule, like if you remember, we had AB to the power n rule. We can apply that one too. If I apply that, I get this thing. 1/3 to the power -2, x4 to the power -2, y -3 to the power -2. Now we can use the power of power rule. This is same as, now here we see a division. Then this becomes 1 to the power -2 divided by 3 to the power -2. I'm not going to repeat which rule I'm using, but you know, you can clearly see what I'm applying here. And here I use the multiplication of powers, -8, y, +6. All right, so we have done something. Now let's check the conditions. Each real number appears only once. That's okay, but not all exponents are positive. So let's do more calculations. So I can see that now what is this one? 1 to the power -2. We can write it as 1 divided by 1 to the power +2. Now 1 square is just 1, so this is 1. Okay, so then this is 1. Now how about 1? Wait, let's do it at the next step. Let's keep it 3 to the power -2 here. Now how about x to the power -8? We can write it as 1 divided by x to the power 8. So this is same as x8 and y6 here. All right, now what can you say about this? 1 divided by 3 to the power -2. This is same as 3 to the power +2. All right, so here we have 3 to the power +2, y6, and divided by x8. We can rewrite 3 to the power 2 as 9 by 6 divided by x8. All right, does it satisfy the conditions now? Yes, x appears only once, y appears only once, and all exponents are positive. So we can stop the process. So this is my final answer for this question. All right, let me take another example, my final example. This example consists of powers of negative numbers, which I was emphasizing in the previous video. That is very important. So I have -2 times r4 s -3 whole thing to the power -2. All right, so now we have to be careful with this negative number. Now we see a parenthesis. That means this negative 2 is applying to this negative sign. So if we apply the rules now, what do I get? Rules means laws of exponents, right? So I can rearrange this as this if you want. Here this is a multiplication symbol, right? It's not an x. All right. Now let's apply the laws. Then this becomes negative 1 to the power negative 2, 2 to the power negative 2, r4 negative 2, s negative 3, negative 2. Now we see negative exponents, so that means it's not simplified yet. Now what is this? Negative 1 to the power negative 2. So this is same as 1 divided by negative 1 parentheses to the power 2. Don't forget this parentheses, it is very important. And this is 1 divided by positive power. And this is r negative 8 s positive 6. Still we see negative powers. Now this thing. Negative 1 square means just 1. So this becomes 1 over 4 we can write. And S6 and R negative 8 can be written as R positive 8. Alright, now we see only one S, only one R, and all exponents are positive. So that means this is simplified. So this is my answer. Alright, so we talked about the meaning of simplification and we went over a couple of examples. So now you know how to start the simplification process. You can apply the laws of exponents and you know when to stop, right? You have to check these two conditions every time, maybe at each step, so that you can decide the place where we should stop the process. So the conditions are each real number should appear once and all exponents should be positive. Alright, so I think you enjoyed this video. Thank you so much for watching. So I will bring the next lesson in soon. So as I always say, please subscribe to my channel if you haven't done already. And if you enjoyed this video, like it and share it with your friends. Okay, so have a nice day and stay tuned.